Who's ready to train and evaluate Model 0? Put your hand up. I definitely am, so let's do it together. We're going to start off section 7.7 and we're going to put in train and evaluate Model 0, our baseline model on our custom data set. Now, if we refer back to the PyTorch workflow, I issued you the challenge in the last video to try and create a loss function and an optimizer. I hope you gave that a go, but we've already built a training loop. So we're going to leverage our training loop functions, namely train, train step, and test step. All we need to do now is instantiate a model, choose a loss function and an optimizer, and pass those values to our training function. So let's do that. All right, this is so exciting. Let's set the random seeds. I'm going to set torch manual seed 42 and torch CUDA manual seed 42. Now remember, I just want to highlight something. I read an article the other day about not using random seeds. The reason why we are using random seeds is for educational purposes. So to try and get our numbers on my screen and your screen as close as possible. But in practice, you quite often don't use random seeds all the time. The reason why is because you want your model's performance to be similar regardless of the random seed that you use. So just keep that in mind going forward. We're using random seeds to just exemplify how we can get similar numbers on our page, but ideally, no matter what the random seed was, our models would go in the same direction. That's where we want our models to eventually go. But we're going to train for 5 epochs, and now let's create recreate an instance of TinyVGG. We can do so because we've created the TinyVGG class. So TinyVGG, which is our Model 0. We don't have to do this, but we're going to do it anyway, just so we've got all the code in one place. TinyVGG, what is our input shape going to be? That is the number of color channels of our target images. And because we're dealing with color images, we have an input shape of 3. Previously, we used an input shape of 1 to deal with grayscale images. I'm going to set hidden units to 10 in line with the CNN Explainer website. And the output shape is going to be the number of classes in our training data set. And then, of course, we're going to send the target model to the target device. So what do we do now? Well, we set up a loss function and an optimizer. Loss function and optimizer. So our loss function is going to be, because we're dealing with multi-class classification, NN cross entropy, if I could spell, cross entropy loss. And then we're going to have an optimizer. This time, how about we mix things up? How about we try the Atom optimizer? Now, of course, the optimizer is one of the hyperparameters that you can set for your model, and a hyperparameter being a value that you can set yourself. So the parameters that we want to optimize are our Model 0 parameters, and we're going to set a learning rate of 0.001. Now, recall that you can tweak this learning rate if you like, but I believe, did I just see that the default learning rate of Atom is 0.001? Yeah, there we go. So Atom's default learning rate is 1 to the power of 10 to the negative 3. And so that is the default learning rate for Atom. And as I said, oftentimes different variables in the PyTorch library, such as optimizers, have good default values that work across a wide range of problems. So we're just going to stick with the default. If you want to, you can experiment with different values of this. But now let's start the timer, because we want to time our models. We're going to import from timeIt. We want to get the default timer class, and I'm going to import that as timer, just so we don't have to type out default timer. So the start time is going to be timer. This is going to just put a line in the sand of what the start time is at this particular line of code. It's going to measure that, and then we're going to train Model 0. Now, this is using, of course, our train function. So let's write Model 0 results. I nearly wrote Model 1, but we're not up to there yet. So let's go train model equals Model 0. And this is just the training function that we wrote in a previous video. And the train data is going to be our train data loader. And we've got train data loader simple because we're not using data augmentation for Model 1. And then our test data loader is going to be our test data loader simple. And then we're going to set our optimizer, which is equal to the optimizer we just created, the friendly atom optimizer, and the loss function is going to be the loss function that we just created, which is NN cross entropy loss. Finally, we can send in epochs is going to be num epochs, which is what we set at the start of this video to 5. And of course, we could train our model for longer if we wanted to, but the whole idea of when you first start training a model is to keep your experiments quick. So that's why we're only training for 5. Maybe later on you train for 10, 20, tweak the learning rate, do a whole bunch of different things. But let's go down here, let's end the timer, see how long our model took to train. End the timer and print out how long it took. So in a previous section, we created a helper function for this. We're just going to simplify it in this section, and we're just going to print out how long the training time was. Total training time. Let's go end time minus start time, and then we're going to go we'll take it to 3 decimal places, hey? Seconds. You're ready to train our first model, our first convolutional neural network on our own custom data set, on pizza, steak, and sushi images. Let's do it. You ready? 3, 2, 1, no errors. Oh, there we go. Okay. Should this be trained data loader? Did you notice that? What does our train data take as input? Oh, we're not getting a docstring. Oh, there we go. We want train data loader. Data loader, and same with this, I believe. Let's try again. Beautiful. Oh, look at that lovely progress bar. Okay, how's our model is training quite fast. Okay. All right. What do we get? So we get an accuracy on the training data set of about 40%, and we get an accuracy on the test data set of about 50%. Now, what's that telling us? It's telling us that about 50% of the time our model is getting the prediction correct, but we've only got 3 classes. So even if our model was guessing, it would get things right 33% of the time. So even if you just guessed pizza every single time, because we only have 3 classes, if you guessed pizza every single time, you get a baseline accuracy of 33%. So our model isn't doing too much better than our baseline accuracy. Of course, we'd like this number to go higher, and maybe it would if it trained for longer. So I'll let you experiment with that. But if you'd like to see some different methods of improving a model, recall back in section number 02, we had an improving a model section, improving a model. Here we go. So here's some things you might want to try. We can improve a model by adding more layers. So if we come back to our tiny VGG architecture, right up here, we're only using 2 convolutional blocks. Perhaps you wanted to add in a convolutional block 3. You can also add more hidden units. Right now we're using 10 hidden units. You might want to double that and see what happens. Fitting for longer, this is what we just spoke about. So right now we're only fitting for 5 epochs. So if you maybe wanted to try double that again, and then even double that again. Changing the activation functions. So maybe ReLU is not the ideal activation function for our specific use case. Change the learning rate, we've spoken about that before. So right now our learning rate is 0.001 for Atom, which is the default, but perhaps there's a better learning rate out there. And change the loss function. This is probably not, in our case, not going to help too much because cross-entropy loss is a pretty good loss for multi-class classification. But these are some things that you could try, these first 3 especially, you could try quite quickly. You could try doubling the layers, you could try adding more hidden units, and you could try fitting for longer. So I'd give that a shot, but in the next video, we're going to take our Model 0 results, which is a dictionary, or at least it should be, and we're going to plot some loss curves. So this is a good way to inspect how our model is training. Yeah, so we've got some values here. Let's plot these in the next video. I'll see you there.